We are going to discuss about crystal lattice and unit cells. Crystal lattice, or the other name for crystal lattice is space lattice. Now, we know that crystalline solid has a definite geometrical arrangement of constituent particles. Suppose we try to represent the constituent particles as a three-dimensional arrangement. We consider these constituent particles as points. And we can define a crystal lattice or space lattice as a regular three-dimensional arrangement of points in space is called a space lattice or crystal lattice. And I am going to show a portion of three-dimensional cubic lattice. So when I say three-dimensional cubic lattice, it will have the shape of a cube. Now, large number of such cubes will together form crystal lattice or space lattice. So, what is the definition of space lattice or crystal lattice? It is the regular three-dimensional arrangement of points in space. Now, let us see the characteristics of the crystal lattice. The first characteristic is each point in a lattice is called lattice point or lattice site. So, we have in the crystal lattice something called lattice point or lattice site. Now, the second characteristic is each point in a crystal lattice represents one constituent particle, which may be an atom, molecule or ion. So, that is the second characteristic. So, I can say there are 8 corners for a cube. So, 1, 2, 3, 4, 5, 6, 7, 8. And these corners which are represented by points, they are known as the lattice point or lattice site. And each point represents one constituent particle. And this constituent particle can be an atom, molecule or ion. Now, the next characteristic is lattice points are joined by straight lines to bring out the geometry of crystal lattice. So, when I join the lattice points with a straight line, I get the shape for that crystal lattice. And I told you I have drawn here a three-dimensional cubic lattice. Okay, so this is about crystal lattice. Now, next let us see the meaning of the word unit cell. Unit cell. Now, actually I have drawn, what I have drawn here is a unit cell. Now, large number of unit cells will together form space lattice or crystal lattice. So, what do you mean by a unit cell? We can say unit cell is the smallest portion of a crystal lattice which, when repeated in different directions, generates the entire lattice. That is unit cell. Okay, and you can see here, this is the picture of a crystal lattice. Now, you can see here, this is a unit cell and this is a crystal lattice, and large number of unit cells joined together to form the crystal lattice or space lattice. Now, let's see what are the characteristics of a unit cell. So, this is the unit cell which I have drawn, and large number of unit cells joined together to form a crystal lattice. So, what are the characteristics of a unit cell? A unit cell is characterized by 3 edges A, B, C. So, these are the 3 edges of a unit cell. A, B and C. This is one edge C, this is the edge B. So 3 edges for a unit cell. And these edges may or may not be mutually perpendicular. Now the second characteristic is they are characterized by angles between the edges denoted by alpha, beta and gamma. And alpha is the angle between B and C, and beta angle between A and C, and angle between A and B is gamma. So you can say a unit cell is characterized by axial angles and axial edges. 3 axial edges denoted by A, B, C, and 3 axial angles denoted by alpha, beta and gamma. So these are the characteristics of a unit cell. Now next let us see the types of unit cells. Types of unit cells. So unit cell means it is the smallest portion in a crystal lattice. Now what are the different types of unit cells? Unit cells are mainly divided into 2 types. The first one is primitive unit cell or simple unit cell. Primitive or simple, or this is also called basic unit cell. All the 3 means the same: primitive or simple or basic unit cell. Now what do you mean by a primitive unit cell? A unit cell in which the constituent particles are present only at the corners. That is called a primitive unit cell. Okay, so the constituent particles, if they are present only at the corner positions of the unit cell, it's called a primitive unit cell. So how can you show a primitive unit cell? And I'm going to show a cubic unit cell. Now, if this is a primitive unit cell, then the constituent particles are present only at the corners. So we have the constituent particles present at 8 corners of the cube. So this is our simple or basic or primitive unit cell. Now the next type of unit cell is centered unit cell. Second type is centered unit cell. Now centered unit cell means in centered unit cell there are constituent particles at the corners. Now in addition to those particles at the corners, we have particles at other positions also. These are called centered unit cells. So if the constituent particles are present at positions other than at the corners, we call them centered unit cells. Now centered unit cells are divided into 3 types. The first one is body centered unit cell. In body centered unit cell, the constituent particles are placed at the corners, plus they are also present at the center of the body or body center. So they are called body centered unit cell. Now if you draw the diagram of a body centered unit cell, it will be, again I am drawing a cubic unit cell. Body centered, we have atoms at the corner or constituent particles at the corner, 8 corners, plus 1 at the body center. So this is the body center. We have one here. So this is body centered unit cell. Now next type of centered unit cell is face centered unit cell. Face centered unit cell. Now face centered unit cell has atoms at the corners, plus we have atoms at the faces of the unit cell. And you know, for a cubic unit cell there are 6 faces for a cube. So if it's a cubic face centered unit cell, it will have atoms at 8 corners and atoms at 6 faces. So when you draw the face centered unit cell, we have the constituent particles at the corners and also at 6 faces. This is 1, 2, 3, 4, 5 and 6. 1, both on opposite sides, opposite faces. So this is face-centered unit cell. Now the third type of centered unit cell is end-centered unit cell. C is end-centered. Now in end-centered unit cell, the constituent particles are present at the corner plus at the 2 opposite faces. 2 opposite faces. So if you are to draw the end-centered unit cell, we can draw like this. Constituent particles at the corners, 8 corners, and any 2 opposite faces. So I am going to show one here, opposite face 1 here. So this is an end-centered unit cell. Okay, so these are the different types of unit cells, mainly 2 types, primitive and centered. Centered is again divided into 3 types. First one is body-centered unit cell, second is face-centered unit cell, third is end-centered unit cells. Now next we are going to see, depending on the axial and angular parameters, that is axial and angular A, B, C, and angular is alpha, beta, gamma, the unit cells are classified into 7 crystal systems. So next, crystal systems. So there are 7 crystal systems, and this classification is based upon the axial and angular parameters, which means they will have different values for axial and angular parameters. Okay, now let's see the name of these 7 crystal systems. The first one is called cubic crystal system, cubic. So in cubic crystal system, the lattice type present is primitive, then body centered and face centered. These are the 3 types of lattices present in cubic crystal system. Now let's see about the axial distances. So axial distance for cubic crystal is A is equal to B equal to C. All the 3 edges are equal. Now next let's see about the axial angles. Axial angles in cubic system is alpha equals beta equals gamma equals 90 degree. And the example for cubic crystal system, I'll write the examples here. Example for cubic crystal system is sodium chloride, then copper. These are the 2 examples for a cubic crystal system. So if you look at the crystal structure of copper atom, it has a cubic crystal structure. Now the second type of crystal class is tetragonal. Second type is tetragonal. An example for tetragonal crystal class is tin oxide, then calcium sulfate. These are the 2 examples for tetragonal. Now let's see the possible lattice type in tetragonal crystal system. The possible lattice is primitive and body centered. And the axial distance is A equal to B not equal to C. And the axial angle is alpha equals beta equals gamma equals 90 degree. Now the third crystal class number 3 is orthorhombic. Orthorhombic. An example for orthorhombic crystal class is rhombic sulfur. Rhombic sulfur. Now potassium nitrate, KNO3. And the lattice type present in orthorhombic is, we have all 4 types of unit cells in this. That is primitive, then body centered, face centered, and end centered. Now the axial distance in orthorhombic is A not equal to B not equal to C, and the axial angle is alpha equals beta equals gamma equals 90 degree. So this is the third crystal system. Now number 4. 4 is hexagonal. Hexagonal crystal system, and hexagonal crystal system example is graphite and zinc oxide. And the possible lattice type is primitive. Only primitive lattice type is possible for hexagonal. And axial distance for hexagonal is A equal to B not equal to C, and the axial angle is alpha equals beta equals 90 degree and gamma equals 120 degree. So this is number 4. Now number 5, the 5th crystal class is rhombohedral. Rhombohedral or trigonal. An example for rhombohedral or trigonal is cinnabar or HGS, mercuric sulfide. Now the lattice type present is again primitive, and here the axial distance is A equals B equals C, and axial angle is alpha equals beta equals gamma not equal to 90 degree. Alpha equals beta equals gamma not equal to 90 degree. Now number 6, the 6th type of crystal class is monoclinic. An example is monoclinic sulfur and also sodium sulfate. Now the type of lattice present is primitive and end-centered. Now the axial distance in monoclinic is A not equal to B not equal to C, and the axial angle is alpha equals gamma equals 90 degree and beta not equal to 120 degree. Now the last type of crystal class, 7, is triclinic. An example is potassium dichromate. Copper sulfate is an example for triclinic crystal. And the lattice type present is primitive, only primitive type. And the edge length is A not equals B not equals C. And the axial angle is alpha not equal to beta not equal to gamma not equal to 90 degree. So these are the 7 crystal classes. The 7 crystal classes are cubic, tetragonal, orthorhombic, hexagonal, rhombohedral or trigonal, monoclinic and triclinic. Now, when you take the 7 crystal classes, there are 14 different types of lattices. You can count here. There are 14 different types of lattices. Let's start from the first one, the lattice type. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So these 14 different types of lattices are known as Brevis Lattice. So what are Brevis lattices? They are the 14 possible 3-dimensional lattices. They are called Brevis Lattice. So with this we finish the unit cells and its types. Thank you.